Hello everyone, Mr. John here from Areteem Institute with this week's Thursday Tidbit, where we're going to be continuing our discussion on the probability of picking a perfect NCAA tournament bracket. Spoilers, remember this will not be very likely, but let's jump into a review and discuss a little bit more about what we're talking about. So, quick review of the bracket. It's a 64 team bracket if we're ignoring the first 4 teams. So we have these 64 teams, they're all playing each other until we determine the winners. So some of the stuff we did in the last video, right? There's 63 total games that need to be predicted, one less than the total number of teams, and we can use all of those things to try to get some estimates on a perfect bracket you're choosing. Now, we're focused here on a smaller sub question, right? How about we just focus on a single region? So this is 1/4 or a little less than a quarter because these teams have to play. But remember, probabilities are multiplied. So even if you have a chance of choosing a perfect region, that's only going to get exponentially smaller if you'd have to do that 4 times in a row. But the general idea is we have our 16 teams, 1 through 16. These are the different seeds. And these are supposed to be some measure of the better teams and the worst teams. So as far as our assumptions are going to go, we're going to try to do some assumptions based on those seeds and assuming that the higher seeds are better. Right? This doesn't necessarily need to be the case, but our main goal is to explore how might we use some extra information to look at the chances of picking or getting this region exactly correct this way. So, right, we can use these seeds, or our goal is to try to use these seeds to come up with some estimates or come up with some ideas and use those estimates to estimate the probability of picking a perfect bracket just for that region we're focused on. And let's compare that to a coin flip being used. So, as a quick review, let's do the coin flip for just our perfect region we have here. So one of our first assumptions that we can look at now in this bracket is that the higher seeds are going to be winning, right? So we have the first seed beating the 16th seed, then it plays the 8th seed and it beats the 8th seed, then it plays the 4th seed, then it beats the 4th seed, then it plays the 2 seed, it beats the 1 seed, right? So this doesn't happen all that often in real life, but as far as our estimates are concerned, we are assuming that the higher seed is going to be a higher likelihood in beating the lower seed. So that's where these estimates come in. Right? In practice, maybe you know more about the specific teams, you might change the odds a little bit that way. But just for our purposes, high level purposes, we can just do this all based on the seeds we have this way. Now, if we're doing the coin flip, our main thing then is that each game is a 50% chance per match, per game that we're playing there. So when 1 versus 16 plays, right, this assumption then is that there's a 50% chance that 1 wins. There's a 50% chance that 8 wins, etc. Right? So I'm not going to fill in all of these values here, but the idea is all of these games are 50% chance in this scenario. So we have all of these 50s or 1/2s if you like there. So if that's for this single game, then of course, remember we have 15 games in total, 1 less than the number of teams because 1 team is coming out at the end. So this total chance here is 50%, so 1/2 times 50% times 50%. This is that exponential nature. So we have 50% to the 15th power here. And so this is approximately 0.003% there. So if you want 1% in this case. So already with a coin flip, this is a pretty low chance there. That being said, remember in last video we talked about millions of brackets, tens of millions of brackets being done each year, right? People can do multiple brackets and things like that. So even with this estimate, we would already say, okay, a perfect region probably will happen every once in a while or things like that. But the more interesting question here is, can we use the seed to help us out in that case? So for our purposes here, we're going to do a fairly simple one, right? You could do the research each year, what's the chance that this seed beats that seed? But just for practical purposes and display purposes, let's make things a little bit nicer. So let's just say higher seeds have a better chance of winning against lower seeds there. So we're going to use this to update, improve our estimate. And a natural way to do this would be to say when the seeds are close together, right, they're roughly closer to a coin flip of winning. And when the seeds are far apart, right, then there's a very high chance for the higher seed, the higher ranked team to win that game. So that would be the lower number in terms of the seed there. But kind of higher here means the better team in this case. So, right, and the other assumption we're going to do just to make things nice for us is that we can use actually that difference. So if it's a 1 versus a 4 seed, that's a difference of 3. If it's an 11 seed versus a 14 seed, that's also a difference of 3. So to make things simple, let's just use that difference as our common denominator for estimating those seeds. Now, we did mention last time when we have, like, especially in the first round, 8 versus 9, the seeds that are close to each other, that should roughly be a coin flip. When we have a 1 seed versus a 16 seed, right, that's very unlikely that the worst team wins those games. So we can use that and interpolate from there to come up with an estimate. So if you do that, you get this chart here. So, right, this is our one endpoint, right? So this is like versus, if we think about this as a 1 versus a 16, and that will come up in our example here, right? And this one could be something like when you have that in the first round at least 8 versus 9th seed in that scenario. So this works out pretty nicely. We have these divided here into the different categories, right? We have 8 different categories and we have 50 there. So jumping by 7% each time gives us a rough range of all of these values there. So we are going to use this, and I'm going to fill it in later, but a good way to think about this if you wanted to reproduce it or make sense of the numbers I'm going to be using moving forward, think of this as the 50% if they're the same seed or differ by 1, right? Same seed isn't possible in a single region, but it would be possible in the bigger bracket. So if you wanted to expand this, we have it built in that you could expand it that way. And then 14 or 15 difference in seed is pretty much 99, 100% chance that the better team wins that time. So let's see what this type of estimate is going to be doing using our seeds. Now, I do want to take the time just to remind us of these estimates, start filling some things in, but this is going to be similar just with different numbers. And because we have different numbers now, it's a little bit more tedious than the coin flip scenario, but the idea is the same, right? Our estimate here is that 1 versus 16, this was our 99% chance that that 1 seed beats the 16 seed there. So we have our 99% chance in that scenario. And then here we have our 50% chance for the 8 versus the 9 there. And you kind of see how this bracket is built. Even building this bracket has some interesting questions there. Why is it built in this way? Well, you'll see that it's really built to give the higher seed, the 1 seed, the 2 seed advantages. We don't want those better teams to play until later in the tournament, hopefully. But we could fill in all of our different values in this case, right? All of these are coming from that chart. So maybe jump to the bottom here. So here we have our 92%, and then we have our 57% there, right? So the organization of the chart doesn't really match nicely with the numbers we had that way, but we do have some patterns that start to emerge. Then we have our 85% here and our 64%, etc. So we're filling in all of these missing numbers and things like that there. Then we're left with our 78% and 71% in this case. So we're making some improvements or higher percentages in terms of our estimates because now we have this better team winning in that case. So first round, you would need to multiply these 8 numbers together. And then this stuff continues. Luckily for us, things are a little bit nice here because the way this bracket is built with this symmetry of high versus low, we're going to start seeing the same numbers again. So remember, 1 versus 8, that's a difference of 7. So that has equivalent odds in our system as the 4 versus 13. Right, then we have the difference of 3, so this is our 57 again. And our difference of 5, that is our 64%. So I'm not going to write out the full calculation at the end, right? I am going to fill in all of our percentages here, 57% and 50%. And finally, 1 versus 2 is another coin flip at the end. But right, there is some patterns. We do have a 50% in each round. We have a 57% in the first 3 rounds there as well. But then again, if we multiply all of these numbers together, the 15 numbers together in this case, the chance that you pick a perfect region, so you pick these 15 games perfectly, is approximately equal to 0.1443% in this case. Now, that's still not very high, but remember we're talking about millions of brackets. And this is about roughly 47 times the coin flip method. So if we just did the coin flip each time, this would be much more likely to happen in this case. So 47 times more likely actually there. So, right, these are all estimates, but in terms of rough pictures and things, right, can we expect a perfect region? Probably yes, right? Maybe even each year you would expect somebody to predict a perfect region there, right? Perfect bracket, probably not, or actually really not there. So just as a final quick calculation, right? What if you had a 99% chance of picking each game, right? In the whole bracket. Well, remember 99% chance still needs to happen for all 63 of the games. So if you have 99% and you raise that to the 63rd power, this is still approximately 53%. So if you say, I can guess each game with a 99% accuracy, you would be by far the best predictor of these games in the history of this. You could immediately get a job on any sports network. You could immediately make a lot of money betting on these games. Even if that was the case, you would still only have a little better than a coin flip of picking a perfect bracket, right? So the more you have to do this, the much more exponential things grow, or in this case, decrease. So you really have low odds of picking something perfectly the entire way. That will do it for this video. However, stay tuned for a new topic next week. If you have ideas for that topic, share them with us in the comments below. Otherwise, click a like, subscribe to our channel, really helps us out, and I will see everyone next week. Goodbye.